Good morning from Hawaii. It's about 6:30 in the morning here, and we are getting ready to stream our partial eclipse from Hawaii, followed by totality from our friends in Indiana and Texas. Good morning from Hawaii. It's about 6:30 in the morning here. Right now, we are looking at a live view from a telescope in Indiana. We've got a little bit of clouds on the horizon in Hawaii, and we should be starting to see a bite out of the sun in Hawaii, but nothing yet in Indiana. So we will keep you updated. Until then, enjoy this view.
Hello, everyone. This is Roy Gal from the UH Institute for Astronomy. Welcome to our morning eclipse live stream. Right now, we are sharing a view from Indiana that happens to have clear skies. We've got a crew out at Sandy Beach in Oahu.
And they've got a little bit of clouds, so when it clears a little bit, they're going to try to share the view of the partial eclipse from here in beautiful Hawaii. If you've got questions for us, please go ahead and put them in the chat. If you are joining us at the live stream this morning, we've got a live view up, but it's from Indiana. We've got a little bit of clouds on the horizon here in Hawaii, so we're waiting for the sun to peek out from the clouds so that we can see the beginnings of the partial eclipse here. If you'd like to see our situation right here in Hawaii, this is what we have going on. We've got a news crew out with us. We've got clouds right in front of the uh, sun, and we're hoping those clouds clear so that we can uh, get a good view for you from us here locally, and you can see our little telescope set up right there as well. That telescope has a special filter, and we'll be able to show you the sun once it clears up. So we're going to go back to a live view from Indiana, where we've currently got clear skies, and hopefully that'll hold up. Our partial eclipse will reach its maximum at about 7:12 in the morning, if we can get that for you, and then finish at 7:30, and we'll switch over to Indiana, where totality is going to be at about 7:48 Hawaii time.
Sorry, folks, we're having some trouble with our internet connection in Indiana. They're way out in a field, but you could see the sun, just the contrast so that you could see a flare on the exterior of the sun. I'm going to try to show you our view from here in Honolulu, if we can get that to work. right, I think we've got a view of the sun with a little bit of clouds. So what you're seeing here is the sun trying to peek out from some clouds on the beach in Honolulu, Sandy Beach on the east side. So hopefully these clouds clear up enough for us to see the bite taken out of the sun. It's a common occurrence here for us to have clouds right on the horizon. As the clouds clear, you might be able to see a small group of sunspots on the sun. And then we should start to see a little bite out of the sun. And there it is, right in the, almost in the middle of the sun. You can see a little group of two sunspots. Yep, in the clouds, and you can see the partial eclipse happening there in the bottom right of your screen. That looks pretty good. If the clouds can keep away, we'll keep sending you this stream. Later on, as we pass the maximum here in Hawaii, we'll share some information about how solar eclipses happen. And if you're wondering if you'll be able to see a total solar eclipse from Hawaii, not this time. This time we'll see up to about 30% of the sun blocked. And sadly, there won't be a total solar eclipse visible from Hawaii for the next 2 centuries. So you're going to have to travel to go see one. Oh, thank you, clouds. Passing away, and you can see the moon starting to block out the sun. All right, there we have a beautiful view of the partial eclipse as it's starting to take place here in Hawaii. The clouds have cleared, so those of us watching from here finally get a nice view. If you are at home and you want to take a look, and please make sure you have safe solar viewing glasses, and you'll need to be on the east side of the island, someplace where you can see the sunrise, because this will be over in about 45 minutes. We have about 20 minutes or so till we see the maximum eclipse here in Hawaii, which is going to be about 30%. We will be streaming with you here until about 9:30 in the morning Hawaii time, as we're going to switch over to colleagues who have telescopes in Texas and Indiana where they will see totality. Right now, Indiana has clear skies, and Texas, they're chasing the areas looking for a patch of clear sky to be able to join us. And that dark stuff that you see passing in front of the sun is just the clouds. It's not smoke, not a fire or anything like that. We've just got some clouds on the horizon, but you can still see the bite taken out of the sun in the bottom right corner. And we're bringing this to you from a small digital telescope called an EV scope that we've got set up on Sandy Beach, and it has a safe solar filter on it as well. So let's keep our fingers crossed for the clouds clearing again, and so we can see the sun better. Astronomers are always at the mercy of the clouds unless we're using something up in space like Hubble Space Telescope or James Webb Space Telescope, and we're not going to use those to stare at the sun. So we do have to wait for the clouds to clear before we can show you any more images. So while we wait for the skies to clear, again, let's share some information about eclipses and how they happen. So let's get this going here. 1 minute. So what we're experiencing today is the shadow of the moon cast on the Earth. So in this graphic, which is not to scale, you can see that the light from the sun comes, and usually it's hitting the Earth. And you can see that when the moon is directly in the path of the sun, it creates a shadow on the Earth, and the dark part is called the umbra, and the lighter part is called the penumbra. And we do not have a lunar eclipse every month, even though the moon goes around the Earth every month, because the moon's orbit is tilted compared to Earth's orbit around the sun. So as the moon goes around the Earth, sometimes it's below where the sun appears, and sometimes it's above. And so you need to have the perfect alignment that the moon is in line with the line between the Earth and the sun when it's also in between the Earth and the sun, and that's when you get a solar eclipse like what we're seeing today. When you get a lunar eclipse, then what you get is that the sun is in between the uh, uh, then the sunlight is blocked. The Earth is between the sun and the moon, so you get a lunar eclipse. And because the Earth is much bigger than the moon, it's easier for us to get lunar eclipses. The Earth's shadow is bigger than the moon's shadow, so we see lunar eclipses much more often than we see total solar eclipses. So we're lucky this is the situation we have today. And today we're going to get a total eclipse. But because the moon's orbit is not only tilted, it's a little bit of an ellipse. Sometimes the moon is closer to Earth and sometimes it's farther away. When the moon is farther away, it looks smaller, so it doesn't quite block out the sun, and you get what's called an annular eclipse. Some people call it a ring of fire. But today we're lucky the moon is closer in its orbit to the Earth, and so we are getting a total eclipse. And if you have a situation where the moon is not quite perfectly aligned up between the Earth and the sun, you get a partial eclipse. So that gives us the eclipse geometry. It looks like the sun might be starting to peek out from behind the clouds, so we will switch back to our telescope in Sandy Beach if we can very soon. So we are going to try to switch back to our view from Sandy Beach. There we go. There's a nice view from Sandy Beach. Got a pretty good chunk taken out of the sun. We're still fighting the clouds, but we'll try to stick with that for a while, even if it goes dark from the clouds. And I'd really like to thank our students who are out there at Sandy Beach. Those are some of our undergraduate astronomy majors, Mark Achenbach, Kiana Ejercito, and Gianna Longo, and one of our graduate students, Andrew Hoffman. They're out there talking to the nudes, running the telescope, helping with this stream. So if you're interested in a career in astronomy and are thinking about places to go to college, why don't you come join us at the University of Hawaii? It is actually a beautiful day here in Hawaii, although we've got some clouds right on the horizon, which is, of course, where we're seeing the eclipse because it is just after sunrise here. And if you've been watching, you can tell that quite a bit more of the sun is blocked by the moon than we had earlier. We're about 15 minutes away from the maximum eclipse here in Hawaii.
And our eclipse will be completely over at 7:55, which will be just after Indiana starts to see its first contact. So we'll probably switch over to Indiana right near the end of our partial eclipse, where we've got our colleague Alex Dzierba and his friends Nick Wilford and Henry Wyland running telescopes for us. There's a nice, beautiful, clear view. We've got a nice group of two sunspots there and a smaller one in the lower left. If you're viewing this through your eclipse glasses, then you may see the orientation of the sunspots is different, or the orientation of the eclipse is different, and that's because telescopes uh, flip images around depending on the number of mirrors and the way they're set up. All right, there's a nice, beautiful, clear view of the partial eclipse from here in Hawaii at Sandy Beach on the east side. Maybe there's some people out enjoying a swim in the water, and hopefully they might have even taken some eclipse glasses with them to take a look at the sun from the ocean. If you're wondering where you can see another total eclipse because you didn't get to see this one, there are quite a few coming up in the next couple of years. There's going to be one in August of 2026 that you'll be able to see from Iceland and much of Spain. There will be one in August 2027 that will be visible from North Africa, parts of the Middle East, the very southern parts of Spain and Portugal, a little bit of the Mediterranean Ocean. And then for those of us in Hawaii, for some easier travel in July 2028, there's an eclipse that passes through basically the middle of Australia, including major cities like Sydney. And if you're interested in seeing a Ring of Fire eclipse, the next one of that is in October of this year. And that you'll have to go way southern Chile or Argentina to see it. And then there's one in February 2026. That one's the hardest to get to all the way in Antarctica. February 2027, Argentina gets a second Ring of Fire eclipse. And in January 2028, there's a pretty spectacular one that passes through Brazil, Ecuador, Peru, and then across the Atlantic Ocean and actually ends up visible in some of Europe, including France. And it looks like we are back in clouds here in Hawaii. So we're gonna uh, keep a keep that view on in case the sun peeks out. And if it doesn't look like the sun's going to peek out soon, we'll share some eclipse graphics. Oh, and we can see bits of it. All right, looks like we are in uh, some clouds. So we're going to switch to some informative slides and show you something about eclipses, and we'll have our team let us know when we can see the sun again. So we were talking about some future total eclipses. So for those of us in Hawaii, this one will be the easiest to get to in July 2028. There's one that passes right through Australia. And we mentioned some of the ones coming up soon. You can see the path of totality for this one in 2026 crosses Iceland and into Spain and places like Barcelona. And then the one in 2027 goes through North Africa and into some of the Middle East. And we talked about the how eclipses are caused by the shadow of the moon on the Earth. And we're just going to pop to something that we'll see later today when we switch to Indiana with an all-sky camera. During totality, the sky gets quite dark, similar to late in twilight. And we actually have quite a few planets that will be visible. And you'll be able to see Venus, Saturn, Mars, and Jupiter. If you've got a binoculars, you will see Mercury and a comet that's relatively bright as comets go, but that you can see with your binoculars, Comet 12P Pons Brooks. And you can see that the planets are all going to be lined up in a line that is the plane of our solar system that we call the ecliptic. And we're just happen to be lucky that the uh, planets are all visible at the same time. And this view that we're showing you now is actually a view from a space observatory, the Solar and Heliospheric Observatory, SOHO in space, taken last night. And you can see the same groups of sunspots that we were showing you today, but this gives it to you in a little more detail. And just so you can see what's happening in Hawaii, I think we're going to have a view from uh, Hawaii soon once the clouds part, and you can see the news crew and a lot of people out at the beach enjoying things. I'm going to share the live image from Indiana right now. So here we go. This is our live view from Indiana. So you can see in Indiana, the eclipse has not started yet. The eclipse happens at different times on different parts of the Earth because your part of Earth basically has to rotate into the moon's shadow, and the moon is also moving around the Earth. So you've got to have that alignment happen. So it does not happen at the same time on Earth in the same everywhere. So we will see the shadow of the sun racing across the Earth over time. And so in Indiana, their eclipse starts at about 7:48 a.m. Hawaii time, and then they get their totality just after 9 a.m. Hawaii time. And by then, our partial eclipse will be over. So right now, we've got a view from Indiana, and let me see, it looks like the sun is coming out. So I will switch over to a Hawaii view. All right, we should be switching back to a view from Hawaii here soon. All right, here we go. Got beautiful skies in Hawaii. All right, we are approaching the maximum eclipse from Hawaii, so we get about 29% from here in Oahu, and even the short distance change to the Big Island gets us 33% or so. So hopefully people around the islands are enjoying the view with their safe solar viewing glasses. Those little black dots that you see on the sun are part of the sun. Those are sunspots. Sunspots are cooler areas of the sun where the magnetic field of the sun peaks out and it can cool a little bit. The surface temperature of the sun is about 10,000 degrees Fahrenheit, about 5,700 degrees Kelvin, 6,000 degrees Celsius. And those sunspots are about 1,000 degrees cooler. So they're still extremely hot, but because they're not as hot as the rest of the sun, they appear cooler. And they come and go as the magnetic field of the sun changes. The sun goes through a cycle of more and less magnetic activity every 11 years. And we're actually in a part of relatively high activity. And there's other sunspot groups that we can't see that are on the backside of the sun right now. But if you want to be impressed, perhaps, the smaller sunspot group that we see in the lower left on our image is about the size of the Earth. So if we put the Earth right up next to the sun, we would be one of those small black dots. We would easily fit inside the larger sunspot group that we can see. And if you got a safe solar filter and you're viewing the sun live yourself right now, you might see it appearing a different color. Some of the filters are made out of different materials, and plus our telescope sensor has different sensitivity than our eyes and is also set up to deliver an image that looks more orangey just with the software. And I think I saw in one of our other white light images earlier that there's even some prominences that we might be able to see later. So when we switch to a special filtered telescope in Indiana later, we'll might try to show you one of those. All right, we've got a beautiful view of the maximum eclipse here in Honolulu. That view is from our undergraduate students, Mark, Kiana, and Gianna, and graduate student Andrew, who are operating a digital telescope remotely at Sandy Beach in Oahu. Looks like it's kind of windy there and it's knocking the telescope around a bit, but we've still got a good view going.
Shots again from
Yeah, the wind's picking up a bit, and we got a couple of raindrops for a second, but nothing too bad.
for astronomy.
All right, here is a beautiful view of our partial solar eclipse from Honolulu, Hawaii, out on the east side at Sandy Beach. The skies have cooperated and given us some clear skies right for our maximum, and we're going to stay here until our partial eclipse ends in about 20 minutes or so. For those of you who are watching live on YouTube, I've also tried to join there while speaking to you, and I'll start to try to answer some questions over there. And we do have clouds coming and going, as you can see. We also like to thank the crews from KITV News who came out to join us. And I know that another news station is out with our friend Nick Bradley from Stargazers of Hawaii at another beach. I think they're out in Kailua. So everyone is hopefully enjoying a good view of the eclipse, even if they can't quite see it in person. And we are going to stay live for the next few hours because we have a colleague, Alex Tierba, who is in Indiana, who has telescopes set up there. In fact, he's got 3 telescopes set up there, one that will give us an image similar to this one, another that has a special filter to help highlight prominences and the sunspots, and then hopefully an all-sky camera as well that will let us see the lineup of planets and everything like that during totality. And then we have a colleague from the University of Hawaii at Hilo, Pierre Martin. He's one of the astronomers there, but he has traveled to Texas to try to catch the eclipse, and they are fighting with clouds even much more than we are right now. So we'll see if he can join us and share from his totality as well. The Hawaii peak eclipse was about 29% at 7:13. And you're going to have to wait a while because the totality in Indiana is at about 9:04 a.m. our time here in Hawaii. And we're actually lucky to be living in a time where we can share all these images uh, live from across the world and chase totality and things like that. And we'll take occasional breaks to share some slides with information about eclipses. You can see that the moon is already starting to cover less and less of the sun here in Hawaii if you're following our stream. And you can see the clouds sort of giving us a little bit of a challenge here in Hawaii. Funny enough, the predictions for where cloud cover would be had a lot of people planning their travel for the southern United States and Mexico and staying away from the Northeast. But it looks like actually the Northeast, places like Vermont and Maine, are actually good places to see the eclipse. So, as we know, predicting the weather a year in advance is a folly. And all we could do is go by past statistics. So, a lot of people are scrambling to find places where they can see totality on the mainland. And it looks like we are lucky that Indiana is looking okay right now. It looks like we just got socked in by clouds a little bit. We'll stay over here on our stream in case it clears back up briefly. So if you're seeing a black screen, nothing is wrong. We just have clouds covering things up. And I am watching a camera in Indiana, and I see some thin clouds there too. So we are going to keep our fingers crossed that we're going to have some clear skies for the eclipse there as well. And I can see we have an iPhone looking at the beach out there in Sandy Beach, and I do see that there are some clouds right in front of the sun. So what I'm going to do is switch to the Indiana view real briefly in just a moment here. Let me get that set up. So here we've got a view of the sun from Indiana with a telescope that's filtered to show us the light given off by hydrogen gas. And later on, we will adjust this image. And so the sun will look extremely bright, but then we'll be able to see some of the fainter prominences and flares on the outer parts of the sun. So this is what the sun is looking like right now from Indiana. You can see the same sunspots we had here visible in Hawaii, a nice group of two towards the middle and a smaller one off to the edge. The orientation is different just because the telescopes are mounted differently. And I can see that there's some clouds still out at the beach at Sandy's. So we're sharing this beautiful image of the sun for a moment. I can see it's getting pretty cloudy out there in parts of the beach. We are going to, let's see. I know some of you have been joining us for a while, so you have probably seen some of this information before, but we're going to share some information about eclipses. So we've got this is a view now of what the sun looked like from space a few hours ago. So you can see the same group of sunspots that were visible in our images from Indiana. It's just a little bit higher resolution image from space. And you can see some fainter sunspots that we didn't see in our images. And if you stick around until about 9 in the morning, a little after 9 in the morning Hawaii time, we will have totality from Indiana, weather permitting. And when that happens, we will hopefully be sharing an all sky camera as well as a white light camera. And the white light camera will show us the corona, the outer layers of the sun. And our all sky camera will show us all of these planets lined up in a row. And that should be quite a sight to see. If you ever have the chance to travel to see a total solar eclipse, I highly recommend that you do so. I went to my first one in 2017 on the mainland, and it really was spectacular. And even astronomers who are used to seeing all kinds of celestial sights are quite awed by these. And we actually have a research group led by our astronomer Shadia Habal. Their team is called the Solar Wind Sherpas, and they are traveling. They have 3 locations set up on the mainland with special telescopes studying these outer layers of the sun that can only be done during total eclipses. So they travel to every total eclipse, planning 1 or 2 years, building equipment, planning travel, and then for anywhere between 2 to about 10 minutes of observations. But they get spectacular data on the outer layers of the sun, and we're trying to understand how those outer layers work, how the hot corona is generated, how material flows off the sun and interacts with Earth. And when there are super powerful solar storms, those can cause significant damage to Earth. There was a blackout in Canada, I believe in the 1970s, that was caused by a solar storm. And there was a super strong solar storm called the Carrington event that predates modern technology. The only technology at the time was telegraphs. And there was so much energy coming from the sun that those particles, that energy went into the telegraph wires and in some cases caught the telegraph stations on fire. So you can imagine that an event like that today would knock out power grids across the globe. It could damage our satellites, our internet service. So we like to be able to predict those, and we're not at the point yet where we can quite predict them. So that's one of the important human-focused reasons that we are studying the sun. And if you are interested in traveling for eclipses, here's your upcoming total eclipses and where to visit. August 2026, Iceland. Oh, I just saw an airplane fly in front of our Indiana stream. That was cute. Um, the August eclipse will be visible from parts of Iceland and Spain, and it is the summer in Iceland, so it's actually a very nice time to visit. And then a year later, there's one that passes through North Africa and very southern Spain and some of the Mediterranean. And then you can also go to uh, Australia in 2028. So I'm going to switch back to our Hawaii view as the clouds are clearing. And there we go. We're back to our Hawaii view. You can see the moon is starting to get out of the way. And we can see those same sunspots. Man, I see some clouds coming to cover us up here in Sandy Beach again. It is pretty patchy cloudy there from our camera view of the beach. But we'll keep trying, hoping looks like there's one big cloud and hopefully that will move away soon. There was a good question in the chat about whether different parts of the world get more or less eclipses. And there is some relationship because you need to have the shadow of the moon crossing in front of you. Uh, and the reason for that is that the sun is over the horizon at high latitudes for longer periods of time. So near the equator, like we are here in Hawaii, we get someplace along the equator, we'll see a solar eclipse about every 3 years or so, a little bit less than that. And the uh, polar regions see them closer to every 2 years on average, which is why when we're listing all the different eclipses, and we didn't talk about the annular eclipses, there's been quite a few eclipses that crossed Antarctica or the Arctic or the very southern parts of Chile and Argentina or up in Iceland. And there's more of those than ones that cross over, say, the mainland United States or um, the middle of South America or Africa or Europe or those places. So there is a difference depending on where you are on Earth about how often you get eclipses. It's not huge, but it does make a difference. On the other hand, a lot of the places, the polar regions where they get eclipses more often are harder to get to. And it looks like we are still stuck in the clouds. So just a reminder that the next easiest to access eclipse is going to be Australia. For those of us here in Hawaii, at least. And for those of you who are interested in learning more about what some of our astronomers do when they go on solar eclipse expeditions, you can Google Solar Wind Sherpas. They are a team of astronomers, international team of astronomers, including the UH Institute for Astronomy's Shadia Habal. This is actually her 20th eclipse expedition. She's gone to see 20 total solar eclipses as part of her research. And you can see this beautiful image shows the sun during an eclipse. You can see what's called the diamond ring effect, which is when a teeny part of the sun is still visible through one of the crater edges or something like that on the moon. This is a combination of multiple different images put together. You can see some of the prominences and flares on the sun, but what's in green and highlighted in green and red, which is what you would be able to see during totality in white light with your naked eyes, is the corona or the crown of the sun. That is gas that is millions of degrees hot, that is flowing off the sun, and the different colors represent different temperatures of the gas as mapped by actually iron atoms that have been ionized that have more or less electrons knocked off of them. So you can see there's a very complicated structure of the corona, and you can see it changing in real time and from year to year. And you can see the stripes and things like that that trace the magnetic field of the sun. So you can really see that the sun's outer layers are quite spectacular. And when you are viewing totality, the images do look like this. So let's take a look at some images from their previous expeditions. If I can bring some up. Oh, no, they don't have any. All right. Then let's do this. This individual, Miloslav Drukmiller, is part of their research team, and he does some amazing eclipse photography. And here are some images from previous eclipses. And actually, when you go and look with your naked eye, you can actually see some of this, a lot of this structure of the corona during a total solar eclipse. And I'm told that the sun is coming back into view, so we will go ahead and stop this share and go to a live view. All right, and we are back to a live view from Sandy Beach. Our eclipse is about 18 minutes from being 100% over. And you can see the moon getting out of the way and allowing us to see the sun. All right, we've got a great view of the sun again from Sandy Beach. The eclipse is approaching being over. About 15 minutes left of our partial eclipse here in Honolulu, and then we will switch over to a view from Indiana. Where they do seem to have clear skies right now. I can see our telescope getting blown around by the wind. I can also see the hair of people out there getting blown around. Um, Again, I would like to thank the students who got up extra early to make it out to Sandy Beach and set up by 6 a.m. this morning. That means they were up at 5 or 5:30 in the morning, which I know is an ungodly hour for college students. These are some of our UH Manoa astronomy undergraduate students, Mark Achenbach, Kiana Ejercito, and Gianna Longo, and one of our graduate students, Andrew Hoffman. And they've been out there all morning running this stream for us, talking to the news crew, talking to the people who are out there enjoying the partial eclipse and a beautiful sunrise. We really appreciate their help. And for those of you who didn't know, the University of Hawaii's astronomy program is one of the largest astronomy undergraduate programs in the world. And our astronomy department, the Institute for Astronomy, is the largest university-only astronomy unit in the country. There are some that have universities that have separate astronomy institutions related to, say, NASA or something else attached to them. But as a purely university astronomy department, we are the biggest. And we do have people who study everything from the sun and how it works to comets to the farthest away galaxies. We operate telescopes that search for asteroids. In fact, telescopes developed and operated by the University of Hawaii Institute for Astronomy are responsible for more than half of all new asteroid and comet discoveries right now. And we're funded in part to search for asteroids that could hit the Earth and cause damage or even wipe us out like the dinosaurs were wiped out. So we have a lot of great research going, and the sun is just one of the many things that we study. And we are almost done with our partial eclipse here. So you can see in the corner of our screen, we've got the folks from KITV News. You can see Mark, who's been running the live stream briefly. You can see some of the clouds that we've been fighting and that we're stuck in again. So if you're interested in what telescope we're using, you can use almost any telescope that you want to view the sun, as long as you have a special safe solar filter for the telescope. But we're able to stream with you because this is a digital telescope called an EV scope, which actually, with the filter, you can observe the sun during the day, but at night is capable of taking long, deep exposures controlled from your phone or tablet. And then we've got the tablet talking to a laptop, which is connected via Mark's hotspot to the internet, and then streaming to us so we can share with you. And we are back in the clouds again. I'm going to hang out and see if we can get oh, it looks pretty dang cloudy there actually from the view. So I'm going to switch over to our Indiana view. Let me get that ready for us here. All right, so we are going to switch back to the view from Indiana. And this image of the sun looks quite different. You might see lots of structure in it. And that is because this image from Indiana is not taken with all colors of light, but is with a special solar telescope that looks at light given off by hydrogen gas at a specific color, at a specific wavelength. And it highlights some of the active areas of the sun. And you'll be able to see the sunspots and some of the other features on the sun much better. Oh, and now it looks like the solar telescope the H-alpha scope just went offline. Let's see if we can bring that back. So we'll wait for that to come back. So we were talking earlier about what you might be able to see during totality. And even with your naked eyes, you can see these streamers, the corona coming off the sun. And you can see those out to multiple times the radius of the sun. So this is an image taken and processed by one of the members of our Solar Wind Sherpas team. But those streamers sticking out far, far from the sun are truly visible just with your naked eye during totality. So if you're going someplace to view totality, you'll want to have your safe solar viewers handy. And you'll be watching the sun during the eclipse as it gets closer and closer to total with the safe solar viewers in front of your eyes. And only when you get to 100% totality, you take those solar viewers off, and then you can see this corona. And the feeling of being in a total solar eclipse is really pretty remarkable. The entire color of the sky changes, it gets much darker. It really is like a light switch. Going from 99% to 100% totality is a huge difference. The corona all of a sudden pops out, You can see some stars, some of the bright planets. The animals around start to act strange. Some think it suddenly become nighttime and go to rest. The temperature changes dramatically because suddenly you're in complete shade from the moon's shadow. And it's a pretty awesome experience. That's more than just something that you see with your eyes. It's kind of a whole body sensory experience. The sounds around you change, the wind changes, the animals change, the temperature changes. So if you ever have a chance to go see a total solar eclipse, I highly, highly recommend it. And it looks like we should just about be done with the eclipse here in Honolulu with our partial eclipse, but it looks like we're still in the clouds. We can get a last view of the very end of the eclipse from uh, Hawaii. I'll do that. And we are going to switch over to our Hawaii view right now. Looks like the clouds moved away. Yep, there you can see the very bottom of the sun. There's a tiny, tiny bite taken out, and we're about to get uh, the end of the eclipse in about 8 minutes here. And I know some of you have been asking for the live views all the time, but there have been times when the clouds completely block the sun here and it was pitch black in the image. So we went to show you something different. But we are going to stick with this live view until it's blocked completely, and then I will switch over to the live view from Indiana with occasional switches to do explanations of the eclipse and the geometry for those who join us later during the stream. And of course, just as I say that, we have the clouds rolling back in to cover up the sun here in Honolulu, in and out. There's that tiny little bite out of the sun right at the bottom as we see the moon move out of the way. And I'm going to switch to Indiana soon because I am starting to see the partial eclipse starting in Indiana. I'm seeing just a tiny bite out of the uh, sun there as well. So as this moon is moving out of the way for us here in Hawaii, it is starting in Indiana. So we'll hang out here in Hawaii for just a bit, and then I will switch right over to the Indiana partial eclipse view, which is looking fantastic right now. And just a teeny bite taken out here in our view from Hawaii. The partial started about 3 minutes ago in Indiana, and our partial ends in 5 minutes. So we've got about a couple of minutes of overlap. Okay, I think I'm going to, well, let's wait for things to end here in Hawaii since we've got a nice clear view. If it clouds up again, I will switch over to the Indiana view. And when we switch to Indiana, we're going to see the sun in a somewhat different orientation. It's rotated about 90 degrees from, or 45 degrees from the view we had here, just from the way the telescope's mounted. And the telescope we're going to start looking at in Indiana is looking at hydrogen gas, and we will see a lot of the filaments and other things like that that highlight the temperature and magnetic structure of the sun. But doesn't matter what color we're looking at, it's going to be blocked by the moon. All right, maybe the clouds are telling us it's time to switch over to Indiana, so let's do that here in just a minute. Oh, there we go. We still see a little bit of that bite taken out right at the bottom. If you look right at the bottom of the image, there's a tiny little nibble out of the sun when the clouds clear. There we go. I can see that little nibble now. If you're in Hawaii, then we would like to invite you to come to the University of Hawaii Institute for Astronomy at Manoa annual open house that will be on April 21st, Sunday from 11 a.m. to 4 p.m. at our headquarters in Manoa, right next to the Manoa Public Library and across from Noelani School. We will have hands-on activities, demonstrations, and things like that. Oh, and thank you very much, Mark. He has zoomed in on that bottom limb of the sun so we can just see that tiny bite taken out, and we're going to get to watch the very end of the eclipse. And for those who joined us late, that sunspot that we see, that cooler spot that you can see in the sort of left side of your screen, that's about how big Earth would be if it was right up next to the sun. All right, we've got about 1 more minute of eclipse left here in Honolulu. And then we will bid a fond farewell to the moon being in front of the sun. And switch over to our view in Indiana. As I was saying, come out on April 21st to the IfA, the Institute for Astronomy in Manoa, for our open house, all kinds of hands-on activities, talks about astronomy. Very kid-friendly. Parking is free. They'll be parking in our parking lot, out on the street, and at Noelani School across the way. And it's all free for the community to come see the kind of things that we're doing. And it looks like our eclipse here in Honolulu is done. So I am going to switch over to our view from Indiana in just a minute here. All right, and then here is our view from Indiana. So we've got this great view from Indiana, courtesy of our friend Alex Zierba and Nick Williford. who have set up multiple telescopes. We are very lucky that Alex's father has a ranch right along the path of totality, and they have internet access out in the field. So they are streaming to us live from telescope there. And you can see the sun. Looks like the internet froze for a bit there. But you can see the structure of the sun. This is through a special filter. You can see those sunspots that we saw before are not quite as prominent, but you can see that there is magnetic field around them. If you look carefully around that big sunspot area, there's a sort of lighter area and a darker area. That's sort of like the north and south poles of the magnetic field. And I can see that the images are updating every few seconds. And you can see that the eclipse is well underway over there. And as we get closer to totality, we'll share a white light image from there as well. And then we'll also have an all sky camera so you can see what the conditions are like. For those who are in Hawaii, our partial eclipse is completely done. You can still look at the sun with your safe solar viewers in it, but I don't think you can see the sunspots with your naked eye. They're too small. Sometimes we have sunspots that are big enough to be seen naked eye through those viewers. Otherwise, you can just enjoy the rest of your day or enjoy our live stream coming to you from Indiana. And we've got a while to go till about an hour to go till totality in Indiana. So we'll hang out here and occasionally share some more information about eclipses. We're going to hang out looking at this view from Indiana until it gets closer to totality. That's about an hour away for us here in Hawaii. It's 8 a.m. right now here in Hawaii, and Indiana totality is at 9:04.
by just making sure our connection is live there. So you can see the moon covering more and more of the sun there in Indiana. Sometimes the stream drops out, so I have to go refresh it. So you'll see me doing that occasionally. And when the other live streams from Indiana become available, we'll share that also. For those of you joining us online, we appreciate it. There are other live streams out there as well, but we're happy to have one that's in clear skies in Indiana. So hopefully we'll get you a good view of totality. And in addition to our open house, we can come out to schools. So if you're an educator or a teacher, you can contact us and ask for us to come out and bring out telescopes to look at the sun or do nighttime stargazing, or we have an inflatable planetarium that we bring out, or a star lab that can take about 20 students at a time. We have other hands-on activities, and we've been really proud and happy to partner with many of the schools and school complex areas here in Hawaii to do events where we might have hundreds or even 1,000 students participating in astronomy activities and learning a little bit more about space, how we learn about things that are far, far away from us that we can't touch. And everyone has a great deal of fun and also learn something. I saw someone in our chat mentioning that they were homeschooling their kids. If you are part of a homeschool GUI or group and would like to have us come and do an activity with a group of students, we would be happy to do that as well. We don't just go to schools, we also have regular public events, and we are also happy to work with other kinds of groups. We'll be doing Boy Scout merit badge training in May for their astronomy merit badges with the Pacific Aviation Museum. We've done activities with the Girl Scouts and many other great organizations.
So we're just going to hang out and enjoy this stream from Indiana for a little bit. As it gets closer to totality, I'll keep an eye on the chat for Q&A. And in a few minutes, we'll talk about eclipses again and then hop back to the live stream. So right now we're sharing to you an image taken from a previous solar eclipse expedition that shows you the corona, which people in totality will see. As we wait the next 50 minutes or so till we get totality in Indiana. Our astronomer in Texas is currently driving around trying to find some clear skies. Not too hopeful that he's going to have any luck. Talked to him this morning and it looked pretty bad out there, but they are trying. And here are images, selection of images taken at different wavelengths, different colors of light. So for instance, this is taken through a filter that focuses on specific ionized iron. And you can see the beautiful corona and its complex structure. And if you compare that to a picture taken at a slightly different color, you can see that the structure looks different, and that's because we're mapping different temperature in the sun. And these are by some of our research astronomers who are taking these images as part of eclipse expeditions where they travel all around the world to understand how these outer parts of the sun work. And I'm keeping an eye on our Indiana feeds as well. Although it looks like they're having some internet issues out there, so we'll return to that when we can. They're out in a very rural area in a field, so their internet service is spotty, and they've got quite a few telescopes trying to talk to the world. And I suspect everywhere along the path of totality, everyone's on their phones sharing images and stuff like that. So it's probably keeping the internet service providers there quite busy. But let's take a look at what Indiana looked like just a few moments ago. So there's what we had in Indiana as we are seeing more and more of the sun being eclipsed. You can really see the structures in the sun. I know some people who might be along the eclipse path. Uh, the eclipse has made landfall in Mexico, so hopefully some people are seeing totality there. The cloud cover maps looked questionable for today, but it sounds like some people are starting to experience totality. So the eclipse is going to move across Mexico into Texas and then across the United States. and up into the northeast. We'll keep sharing this beautiful view from Indiana since it gets this amazing structure of the sun visible as the eclipse progresses, and then share some more information about eclipses in a little bit for those who are joining us now. Oh, and there goes the network. So let's go back to sharing some information about future eclipses while we get our network connection here restored. So take a trip to Australia in 2028 to enjoy the eclipse. Or if you want to go sooner and travel a little bit farther from here in Hawaii, there are eclipses visible in 2026 and 2027. And here we have the map of where the eclipse is going to be visible on the mainland. And you can see it's just hitting Mexico, and it'll be crossing over much of the southern Midwest United States. Our friend Al Sierra is up here near Indianapolis, so there's a little while till the shadow moves all the way to there. So people in Mexico, oh, you got someone in the chat saying totality had been experienced in Mazatlan already. And then you can see how the eclipse path is going to change over time. And we'll see if we get some clear skies by the time the eclipse totality makes it to Indiana. If our streams fail, we'll go find another stream that we can share with you that has some images. So let's take a look at the current situation in Indiana. It is getting more and more approaching totality. Still a way to go, about 45 minutes, but it is a quite obvious eclipse if you're watching with eclipse viewing glasses there. But if you were on the ground and you didn't have eclipse viewers, you would probably not tell the difference. It would probably still look like a regular sunny day to you. And that's how it is until the eclipse is pretty much total. It feels maybe a little bit darker, but not significantly, and it happens quite gradually. It's only when totality comes that you really get that sense that something had that something changes very abruptly. If you want to follow the path of totality, NASA has a nice eclipse map that tracks where the totality is happening in real time. If you just go to uh, science.nasa.gov, you can find a link to eclipses and eclipse viewer there. Or go.nasa.gov/eclipse explorer. The next major city that's going to see totality will be San Antonio, probably in about 15 minutes or so. But the weather in Texas has been quite bad. So I don't know if all the people have traveled there, and I know there are a lot. They're probably all scrambling to either get closer to the Mexico border, where I heard the weather was going to be better, or to any place they can to catch a glimpse of totality. So hopefully at totality, we will see something like this in addition to the corona of the sun. You will see a bunch of planets peeking out as the sky is dark enough. We'll also see some bright stars, and there's a faint comet that you will able to see with binoculars for sure. And those planets are all lined up in a nice straight line because that is the path, that is the plane of our solar system. All of the planets orbit the sun in sort of concentric hula hoops, and that's what you'll see there is those that line up that we call the ecliptic, similar to eclipse, right? The ecliptic is the word for the plane of Earth's orbit around the sun, which is also where all the other planets orbit. And we are working on getting our streams up again from Indiana. There just seem to be some network errors going on. So we have to refresh it once in a while. So we have about 40 minutes to go till totality in Indiana. All right, we're back with our live view from Indiana. Looks like we are maybe 40% into the eclipse by now in Indiana. Soon we're going to cover up those beautiful sunspots. And if you look closely at those sunspot regions, you can see an area of light above the sunspot and an area of dark, almost like in a ring. And that is because you can see where the magnetic field goes out of the sun and comes back in. And you can see that in a lot of the regions that there'll be a dark and a light. And those are connected via big lines of the magnetic field. If you've ever done the experiment with iron filings in a magnet where those filings line up in those curvy lines, that's what the sun has. The magnetic field of the sun has a north and south pole, and it's like a horseshoe, and it comes out and back in. And then you can trace that magnetic field with the other material. If we look in this color of light, for instance, if we adjusted the contrast so that you could see flares and prominences, then there would be visible along the edge of the sun. I don't know if there are any there right now. That we saw one earlier, but it was an area that is, I think, currently eclipsed actually. I'll see if we can get our crew who's working this telescope to adjust it if we can see any flares or prominences. So I would like to thank again Alex Zierba, who's got the telescope set up in Indiana. This one is being operated by Nick Williford Nick is actually in the Azores operating this telescope remotely in Indiana, and we are connecting to it from Hawaii and is sharing this stream to the world. So we've got quite a bit of people working from wherever they're located to bring some of this to you. All right, and thank you to Nick who has adjusted the contrast here on their telescope. And if you look carefully along the limb of the sun, you can see some of the prominences. There is one right at about 11:30, almost near the top of the sun. There's actually a big loop, but it's faint, close to where the moon is at maybe 12:30. There is one right here at about I'll call it 8 o'clock, 8:30. So we've got quite a few active regions on the outer parts of the sun. Um, while we're watching this live feed from Indiana, I'm also seeing what's going on elsewhere, and I see NASA's feed has a almost totality, but they don't seem to have a nice big picture of totality right there on their feed either yet. Dallas is getting very close to totality. Looks like they have clear skies. Uh, Other parts of Texas look like they are blacked out by clouds. So we're doing pretty lucky here in Indiana. Oh, let's go see if we can fix this network error real quick. So let's jump back to our informational slide about what we're going to see during totality. All right, looks like our feed is back. It does look like many of the Texas streams are getting clouded out, so we are lucky to have this stream. And again, I was talking about these prominences and solar flares, and you can see I'm trying to circle one. I was circling one. There we go. Those are much bigger than Earth. That flare right there is probably 3 to 4 times as tall as Earth is big across. These little ones that we can see here on the edge, that's about how tall Earth uh, is. And if you look carefully, there's an arch-shaped prominence right here. It's kind of faint and hard to see. I'm not sure how well it comes across on the stream compared to on my big TV here. But you can definitely see a total prominence, and you could put Earth through that, like putting a soccer ball in a net. So this telescope is looking at hydrogen gas, hot hydrogen gas, a specific wavelength of light. And by doing that, it reduces the amount of light that we see from the background sky because we're picking out a very specific color of light where the sun is bright, but the blue sky is not. This wavelength of light is 656 nanometers, so it's kind of in the reddish, orangish reddish portion of the spectrum. And as you know, our sky is blue. So this makes the sky very faint and highlights the uh, bright light from the sun. And those prominences, even though they're bright, are not as bright as the rest of the sun. So we need to kind of block out the light from the sky to be able to see it. And we've really got the brightness cranked up now for you here so that you can really see these active regions on the outer part of the sun. And thank you very much, Nick, for joining us and running this telescope from halfway around the world in the Azores. And so we've really adjusted it so that you can see the faintest outer parts of the sun that are visible now. And then later on, we'll go back to the regular view, turn back down the gain and the contrast, and you'll be able to see the structure of the sun. And he's doing that right now. And you can really see, oh, here's a beautiful little arch as well. That's actually what these are called. They're called arches. And you can see all of the structure along the surface of the sun. Really spectacular. And those flares have nothing to do with the eclipse. That structure on the outer parts of the sun is always there. And with the right telescope and right filters, you can see those all the time. And in fact, the world's biggest telescope for studying the sun is located right here in Hawaii on Maui, the Daniel K. Inouye Solar Telescope. And you might wonder why you need a big telescope to study something as bright as the sun. And the reason is that we are looking at the surface of the sun in great detail, very fine spatial resolution, very fine resolution in different wavelengths of light, and then the magnetic structure, and looking at it basically in real time, trying to get very highly detailed observations to try to figure out how that complex magnetic field of the sun and the energy transport from the inside of the sun to the outside works, and to see if we can build models of the sun that will let us predict the solar weather and the behavior of the sun, since the sun impacts Earth in so many ways. And I am looking at other live streams meanwhile while I'm talking to you. And I saw a live stream from Texas where they're probably a minute away from totality and the clouds just cover them up. So if I do see totality from someplace else where we can share that with you before we get to the one here in Indiana, I will do that. But right now, it looks like we have clear skies and they do not. And now we have got our hydrogen alpha scope, the contrast turned back down so you can actually see the detailed surface of the sun. But now you cannot see those flares unless you look really carefully. There might be one visible right here. I can kind of see. But all of this granulation that you see, all of this graininess, if you look really carefully, is actually the structure of the sun. It's got these cells of turbulence where hot material is coming up from the inside of the sun, cooling down, and then going back downward. And there's amazing videos that you can find online of what's called a solar convection, solar granulation. Thank you to everybody for joining us on this stream. We're happy to provide this resource. I bet all of us wish we could be there witnessing totality, and I do recommend that if anyone has a chance to travel to see a total solar eclipse, that they do so. Our astronomer Shadia Habal, who is the head of our research group that's called the Solar Wind Sherpas, she's out with her team. They have 3 different locations, 1 in Mexico and 2 in the US. This is her 20th total solar eclipse that she's gone to try to observe for science. I've only been to one back in 2017 on the mainland US, and that was pretty spectacular. And I don't know if after getting to number 20, if they lose any of their magic, but they are really worth the visit if you can get to one. And I see that the live stream from Dallas is approaching totality. So I'm going to take a quick jump and share the stream from Dallas that I'm seeing online. So they are just approaching totality in Dallas. And they should have totality right now in Dallas, adjusting the cameras to take off their solar filters. As soon as you hit totality, you got to take off the filter so that you can see the corona. And I saw totality coming, but now I do not see the corona in their images. I think they're trying to get their camera focused and set up. So I'm just sharing. Here we go. There is totality from Dallas. and you can see the corona of the sun. If you look carefully at that image, you can see, uh, looks like they lost their feed. You can see some of the um, fine lines. Don't know why they jumped away from totality, but we have Arkansas. Oh, here we go. Here's a beautiful total eclipse image from Dallas. You can see the structure. You can even see a little bit of a flare right there. I bet their image is rotated to what we had before, and I bet that's one of the flares that we were able to see. And if you watch with your naked eye, you can actually see the corona out to much larger distances, a few times the radius of the sun, just sticking really far out. Oh, there you go. Beautiful, beautiful flare visible right there. And they'll have a few minutes of totality. Oh, I can see another prominence down here. This image is definitely a flipped relative to the one that we had. So you see the prominences in different locations, but they're the same ones. Wow, there's some spectacular. Now they are coming out of totality. They're going to have to take that, put that eclipse filter back on so that they don't damage their camera. And that's what they're doing right now. And totality is done in Texas, or at least in Dallas. That was quite a short totality. Let's go back to our view from Indiana. Looks like it's a little bit delayed. So if you saw that total eclipse image, you didn't see the corona out to those large distances like you see in some of the pretty pictures I was sharing before. And in my experience, when we saw the eclipse ourselves with our eyes, we could see much more of the corona. And my wife was asking me how come that is. And that's because our eyes are what are called logarithmic detectors. So if something looks twice as bright to us, it's not really twice as bright. It's actually much brighter than another object. And so we're able to see faint things and bright things at the same time. Just like if you go out at night and look at the moon, you can see the craters and everything like that, but you can also see bright headlights and street lights. But if you try to take a picture, then if the moon is visible, everything else is dark. And if the moon is bright, then everything uh, else is blown out. So what we see with our eyes and what they're able to show us here on the screen might not be the same. All right, and we have a bunch of stuff going on with our streams in Indiana, so I'm going to try to just switch to this informational graphic here while we get the streams restarted. Yeah, so if you have an opportunity to go see an eclipse in person, it's definitely a completely different experience than viewing it here online. Of course, like I was saying, in addition to being able to see more of the corona with your naked eye, it really is a sensory experience for your ears, your skin. You feel temperature changes, you feel the wind, you hear the animals, and we are getting close to totality. Um, let me All right. So here we have an image from the white light camera in Indiana. So you can see the eclipse approaching totality. We are about 12 minutes away from totality uh, in Indiana. So we're just coordinating here with the various streams that we have coming in. So see, we have both a white light image All right, we have switched back to our Indiana Stream, the Hydrogen Alpha telescope. We are approaching totality in Indiana. I know that the YouTube stream is a little bit delayed, and even some of the video is delayed from Indiana getting to us. But you can see us approaching totality. Even now with this center, you're starting to see some of the prominences sticking out of the sun. And as we get closer, we will switch to the white light so that we can be ready to see the corona when we reach totality. So we've got about 6 minutes or so till totality starts in Indiana. And now we are back to our white light image from Indiana, courtesy of friend of the Institute for Astronomy, Alex Djerba. The hydrogen alpha image we were looking at before was also coming from the same location, operated by Nick Williford. So we are getting close to totality here. So we'll keep on. Alex is
Hi, Roy. It looks really nice here. It's getting very dim.
sharing.
So, guys, look at your shadows on the ground. Very crisp right now. You look at your
As we
hair, you
approach
can see your
totality,
shadow.
since we are only about 4 minutes away from totality in Indiana. This is when, if we were there live, we'd be holding up our eclipse glasses, seeing more and more of the sun covered. Even with the sun covered this much, you would need your eclipse glasses to look at it safely. And to be able to see the moon in front of the sun. If you didn't have that, it would still just look like a bright blob to you in the sky. You could tell that things were starting to get a little bit darker, but it would not be dramatic. And Alex is streaming to us live from near Bloomington, Indiana. So if any of you are paying attention to the NASA Eclipse Explorer or another page that's tracking the progress of the totality, you'll see that we're getting very, very close. It's over Carbondale right now and making its way, just hitting the Indiana border. So about 2 minutes away from totality here. I've heard people ask if we're giving out eclipse glasses for the next one. We don't have a solar eclipse, a total eclipse in Hawaii for 2 more centuries at least, so we don't need any glasses here. And we are actually, unfortunately, just about out of glasses. And we do have fewer eclipses in the equatorial regions because we have fewer hours of sunlight uh, during the day than some of the polar regions. So the polar regions get eclipses about once every 2 years and change, and the average time between eclipses in the equatorial regions is closer to 3 years. It's not a huge difference, but it is noticeable. All right, we are getting very close here. About a minute till totality there in Indiana. So right now, Alex has a solar filter on this camera. And so we can see the sun getting more and more eclipsed by the moon. And when the eclipse is total, he will pop off that solar filter. And then hopefully we'll see the outer parts of the sun. Here we go. Oh, awesome. Beautiful. That's exactly what you would see with your naked eye. Actually, you would see the corona out to much larger distances, but it would be a dramatic change like that. You would be watching with your solar viewer, seeing the sun becoming an ever thinner and thinner sliver, and then you take off your solar viewers at totality and get beautiful streams of material reaching out from the sun. Fantastic. Beautiful stream. Thank you very much, Alex. And you can see the structure in the corona. You can see those lines coming out. You can see some areas that have less material, some that have more up at about 11 o'clock. You can see some streams. Oh, and now with a little bit of an adjustment in the contrast, you can see those red areas that are like the flares and the prominences. It is fantastic. And there we have totality. We're going to have about 3 minutes of totality there in Indiana. And Alex is adjusting the contrast and the integration time so that we can see different parts of the outer layers of the sun. Now we have a pretty decent duration total eclipse this time. That depends in part where you are along the path of totality, whether you're right in the middle or closer to the edge. If you're at the edge of the path of totality, you might only get 30 seconds. But it also depends on whether the moon is closer or farther from the Earth. The moon's orbit is a little bit elliptical, not quite a perfect circle. And so if we get an eclipse when the moon is closer to Earth in its orbit, it lasts longer, it casts a bigger shadow. And if we get an eclipse when we have a mini moon, when the moon is farther away from the Earth, you might not even get totality. You might just get a ring of fire eclipse. And now we've just adjusted this, and you can really see the flares in this one. You can see the beautiful flares highlighted in the reddish color. Remember, we talked that hydrogen gas gives off 656 nanometer wavelength light, and that's kind of reddish. That is the reddish color that you are seeing in those flares. That's why they don't look white. It's because they're not giving off all the different colors of light. It's just hydrogen gas. Someone asked if there are more flares now than maybe in the 2017 eclipse. And yes, there absolutely are. The 2017 eclipse 7 years ago was at a time when the sun was less active in its cycle, and now we are closer to a maximum activity. And there we are just out of totality. So the filter goes back on, and we're going to start seeing the sun peeking out from behind the moon. Wow, what a beautiful view that was. Thank you so much, Alex. That was fantastic. I I think we actually got a better shot than NASA had from their streamers, so that was great. We were very, very lucky to get beautiful weather out there in Bloomington and have clear skies. It was dicey for a while, but that worked out fantastic. And truly, this stream would not have been possible without Alex and his colleagues Nick and Henry working to get ship telescopes out there. Alex actually put up 6 telescopes there, and he's going to have some images to share with us later on, which we'll put on our social media. Yes, someone's pointing out in our chat that there was eclipse visible from here in Hawaii back in 1991. That was our last total solar eclipse. I was not here yet at the time, so I didn't get to see that. One of my colleagues went to go see that back in 1991, and she was out on the near Waikoloa on the Big Island, and it was cloudy where it's usually clear, and her friends who were in Waimea where it's usually cloudy got a clear view of that eclipse. So you never know what you're going to get. You always got to be ready for the weather and to start moving around. But we were lucky that the location Alex chose worked out perfect. And now we are coming back out of eclipse, and there will be quite a while of this eclipse, another a little bit over an hour till it's done. We'll probably stop streaming after about 20 minutes since we saw the approach to totality, and it's going to be just the opposite on the way out. And I know Alex was having trouble with that telescope, and he got it going just in time for us to be able to see everything. So a heroic effort working out in the field on the farm with limited internet access and trying to get multiple telescopes running. So thank you so much, Alex. Yeah, in this feed we are watching a totality. We were watching coverage from Indiana, and we had totality about 6 minutes ago. It ended about 3 minutes ago. So if you just joined us, then I'm sorry, you just missed totality in Indiana, and that's the only other site we have. We had an attempt in Texas, but that was clouded out, which would have been earlier anyway. There are feeds from other places. I know the forecast in Vermont, for instance, up in the Northeast has been quite good. So my guess is that the NASA feeds, which are aggregating from various places, are good. There's also a feed from a group called Unistellar, Unistellar. That's the company that makes the digital telescope that we were using for our Hawaii feed, and they have feeds from various Unistellar users around the country. So you may be able to catch totality from one of those on a live stream. And so as you can see, as soon as we came out of totality and took off and had to put the solar filter back on, all of those prominences, flares that we were able to see before completely disappeared because they really are only visible at that one wavelength of light that's given off by the hydrogen gas. And I know a lot of people are watching the NASA feed. NASA's a little bit more well-known than we are, but we thought we would provide this feed, especially with the partial eclipse here in Hawaii. We had news crew out there with us and separate news crew out with our friend Nick Bradley at Kailua Beach. So locally people could share in the view even if they couldn't get out to the east side of whatever island they're on. And then stick with us as we saw totality on the mainland. And I know my colleague, Director Doug Simons of the Institute for Astronomy, was on TV today also talking about the eclipse. So hopefully he provided some information if you were watching the TV news. And if you have any questions and you're watching us live on YouTube, I am trying to keep an eye on the questions there as they come in. So go ahead and put them in the chat, and I will either answer them in the chat or here live while I'm talking to you. And if you joined us recently, I was telling folks that we have an open house at the Institute for Astronomy in Manoa here at the University of Hawaii on April 21st from 11 to 4, totally free with free parking with lots of family-friendly astronomy, physics, and other STEM, science, technology, engineering, mathematics related activities, hands-on robotics, bottle rockets, Lego, telescopes looking at the sun. Yeah, yep, Cleveland should be experiencing totality right now. If you look at the NASA feed, they have a very nice view of totality, similar to the one that we had, where you can see the prominences, the flares along the edge from Cleveland. So if you missed our view of totality, please grab the NASA feed. I see the New York Times homepage has it on there as well. Probably lots of places where you can grab the NASA live feed and see totality from a distance remotely on our screens. And if you'd like to know what's going on in astronomy, especially locally, the events that we have, discoveries that we're making, please follow us on our social media. We are UHIFA on Facebook, Instagram, and X. And we try to post pretty regularly from activities that we're doing out in the community to discoveries that our astronomers are making. And I'm going to pop away for a moment here from the white light and switch back to our hydrogen alpha telescope so that we can see us coming out of eclipse. And now you should be able to see the same thing we saw in white light and what we saw before the eclipse, but now through looking at this hydrogen light. And you can see that light dark gray modeling on the sun, which actually shows you some of the temperature structure of the outer layer of the surface of the sun. And now we've got this hydrogen alpha set up so you can really see the one of those prominences. Thank you, Nick, for giving us this. Wow, look at that spectacular coronal loop. Look at that, sorry, prominence. Fantastic. That right there, that prominence that's down at about, I don't know, let's say 430 on the sun is probably 5 times as big across as Earth, at least. And you can see, wow, so much detail in the structure of that, as well as in these other ones along the edge. So these outer layers, these prominences and flares are only visible using this hydrogen alpha telescope, not in the white light telescope. And we could see those even when there's no eclipse if we had to use this kind of telescope. but it's much easier to see when a lot of the sun is blocked out and you don't have quite as much contrast. But there's quite a few of them, so you can see that the sun is quite active right now. A big loop here, prominence here, another one here, another one here. There's one up here as well. And then there were quite a few on the other side of the sun. And these prominences and flares last for quite a while. They don't just come and go in a matter of minutes, although they do change their structure over time. And the ones that we're seeing now on what we call the limb of the sun, so the edge of the sun that you can see, if they were rotated towards us, it would be much harder to see. Although sometimes you can see them in these kind of images, but you would see the sunspots that they're connected to. So much of the solar activity is tied to the sunspots, which is where the magnetic field of the sun comes in and out of the sun. And the sun does rotate, just like the Earth, except it takes the sun about 24 days to spin around once. And because it's a ball of gas, it doesn't all quite spin at the same speed. The equator travels at a different speed than the poles. And so that's part of the reason the magnetic field gets all twisted up and complicated, in addition to the internal structure of the sun. And when that magnetic field gets really twisted up, sometimes those magnetic field lines snap and send material spewing out into space, and those are the solar storms that we hear about. And the strength of those solar storms has a sort of letter classification. And if you have the strongest kind and they're going to impact Earth, then that is something that electrical grids need to be ready for. Astronauts in the space station need to go into the module that's the most shielded because the energetic particles can actually damage you when you're not inside Earth's atmosphere for protection. You get strong auroras. And while we think of auroras as only happening in the far north, in the 1930s, I believe there was an aurora that was visible in Hawaii. And so maybe in our lifetimes, we'll get another one of those. That will be quite spectacular. And someone in the chat is commenting about how the brightness change in the sky is very sudden if you're watching one of these eclipses live. And it really is. When the sun is 99% eclipsed, you're still seeing about a 10,000th of the light of the sun, which is still a lot. But when you get to 100% eclipse, you've basically gone to 1 millionth the light of the sun that you normally get. And it really is like a light switch. It's like the stream froze, so let me see if I can get started again. Nope, maybe we'll switch back to our white light stream here in a minute. I'll see if we can get our white light stream restarted here, since it looks like the H alpha is delayed quite a bit. We're back to our hydrogen alpha view with the regular contrast. So now that we see the details on the surface of the sun, as opposed to those prominences, which are much fainter. Soon we'll start to see some of those sunspots that we saw earlier, but even now, if you look carefully, you can see some areas of the sun that are lighter, like right around here, and a little bit darker areas where the magnetic field goes in and out of the sun. The brighter areas are a little bit hotter, and the dark areas are a little bit cooler. And if you missed this eclipse, fear not, there are many other opportunities coming up in the future in different parts of the world. We have in 2026, August 12th, an eclipse will be visible from parts of Iceland and much of Spain. And then a year later, August 2, 2027, August 2nd, 2027, in North Africa, like Morocco, Tunisia, and Algeria, some of the Middle East, like Egypt and Saudi Arabia, and very southern Spain as well. There'll be another eclipse. And for those of us in Hawaii, July 22nd, 2028, and there's a eclipse through Australia. So let me show you what those look like. Here's what the Australia path looks like. And then that will be the Australia path right there. And then soon we'll go back to our white light stream. I think we'll be able to get that from Indiana in just a minute. I am curious what my colleagues who've traveled around the country were able to see. I know we had some people traveling to Texas to see it for fun, and I know that they are probably did not have success. All right, so it looks like they're having some network issues out in Indiana. Worked well, thankfully, during totality. All right, it does look like their scopes are down for now. So we planned for our stream to go till about 9:30, and here we are. That time has come. Definitely looks like there's some network issues there. So thank you again so much for joining us for this live stream from the Institute for Astronomy with me, your host, Roy Gal, our students, Mark Achenbach, Kiana Hercito, Gianna Longo, and Andrew Hoffman out at Sandy Beach in the morning here in Hawaii with Pierre Martin, who we did not see, but who was out in Texas and was planning to join us, but it was clouded out, and friend of the Institute for Astronomy and excellent amateur astronomer and astrophotographer Alex Dzierba, who traveled from Hawaii to Indiana to share the eclipse along with his friends Nick Williford and Henry Weiland who set up other telescopes there, including the H-alpha telescope that we got to enjoy totality from. So thank you again, and come join us at our open house April 21st, and keep in touch with us on social media, and we look forward to seeing you in the future. Oh, and we got a last minute view of the partial eclipse as we were on our way past totality from Indiana. So thank you, everybody, and we are going to sign off from our stream.